All right, here we go. 3A.4 compound interest. Okay. Today is literally an easy day because we're focusing on a formula. Okay. The beauty about a formula is that someone already did the hard work for you, right? They already got the pattern. That was not. They have already found the pattern, and our job is just to now read, mark the text, and plug in what we know. Does that make sense? All right. So our compound interest formula is A, which is our balance after T years, equals P, which is our original amount invested, times 1 plus R, which is our interest rate in decimal form, divided by N, the number of times per year it's compounded, to the N times T power. Okay. All right. So let's dive in. Example 1. So for example 1, we have the amount of $500 is deposited into an account that pays 9.5% compounded monthly. What is the balance in the account after 3 years? So for this problem specifically, we are looking for after 3 years, right? So we're going to go through it and highlight, mark the text, what we already know. We have $500 is deposited. We have a 9.5%. We have that it's compounded monthly, and we have 3 years. So based on this, and it wants us to know what is the balance. Okay. So our P is our beginning amount. Our initial amount is 500. Our R is our rate. What's our rate?
9.5.
What is that in decimal form?
0.9. 0.095.
There we go. And then we have compounded monthly. Compounded monthly means how many months are in a year? 12. So our N equals 12. Okay. Next, it says our T. Our T equals what? And it's asking for our A, our balance. And that's what we do not know. So we're solving for the balance. Okay. Remember, we're using our formula. Our formula is A equals P times 1 plus R divided by N to the NT. So we're going to plug in everything that we know. We're looking for A of 3 equals our P, which is 500, 1 plus 0.095 divided by 12 to the 12 times 3. This just means A of 3, so we're looking for the amount at 3. Just like f of x. Perfect. All right, so at this point, now I just got to evaluate, right? And calculate. So we're going to go to our handy dandy calculator. So whether you choose to use Desmos or handheld, it doesn't matter. I'm going to open Desmos so that if you're doing this at home, you are comfortable using Desmos. Does that make sense? All right, so we're going to type in 500 parentheses 1 plus 0.095 divided by 12, close parentheses, shift 6 to make a power, and it's to the 12 times 3. But notice what happens when I write it like that. Oh, no. Okay. When you have more than one thing to put as a power in Desmos, you have to use parentheses.
So 664 points.
So after 3 years, the amount of money that I would have in my account is $664.14. Do we agree? Okay. It's a because you're just evaluating. So A of 3 equals how much again?
0.14 cents.
And 14 cents. Ta-da! Compound interest. How we feel?
Amazing charity birthday.
All right. Okay. Yes. All right. Guess whose turn it is? It's your turn. All right. Here's yours. Go. Mark, read the text, mark the text, identify your variables. All right, guys, I love the conversations that are taking place. So after you went through and read, important things that you should have highlighted was initially it was 150, right? And then next thing we talked about was 7.5%, and it was yearly, right? And then it wanted to know the cards in 1994. So that's our important stuff. So from there, we now are going to identify our variables. So what is our P? 150. What's our R?
7.5. 0.07.
There we go. What's our N in this case?
1.
1, because it just says a year, right? Each year. Okay. And then finding our T, you have to do a little bit of subtraction. It should have been 6. 1994 minus 1988. Again, the greatest year ever equals 6. You have to use parentheses. I just modeled it for you. All right, so now we plug everything in. So we're looking for our A after 6 years, right? So we have 150. That's not right. I wrote 1,500.
That's a lot of money.
That was a lot right there on accident.
Baseball cards.
I know. 1 plus 0.075 divided by 1 to the 1 times 6. Okay. When I input this in the calculator, is it necessary for me to write those extra ones?
No.
No, but for the sake of writing our formula, I plugged everything in as is. Okay. So we have 150 parentheses 1 plus 0.075 to the 6th power. So after 6 years, this baseball card is now worth $231.50.
Baseball card. Baseball card.
Yep.
The Pokemon Charizard costs $10,000.
Okay, so we get A of 6 equals 200. What'd I say?
231.
And 50 cents. How we feel? Doable? Okay. All right. Okay, this one's a little different. Someone read it for us.
How much would you deposit in an account that pays 6% interest compounded semi-annually to have a balance of 5,015 years?
5,015 years. What is missing from this one?
The total amount. What we started.
There we go. Our initial. We didn't know. We have no clue what we started with, right?
Yeah.
So it gave us our 6.5%. We know that it's compounded semi-annually, which means at least twice a year. And we have 5,015 years. So we're not given our P.
But we are given.
We don't know P, but we do know everything else. We know our R is
6.0. 0.06.
There we go. Moving our decimal places 2 units to the right. We know that our N, because it's semi-annually, is 2. We know that it's gone by 15 years, and we know our A. Our A equals 5,000. Semi-annually means twice a year, but not on like a regular schedule.
Like random.
So it could be like we do it in the fall and in the winter. Yeah.
So can we put P as X?
So P is just going to be, we're going to end up putting P as X, but we're going to write it out. So we know that our A of 15, after 15 years, we've made $5,000, correct? Okay. So that's following. I put that in the, hold on. I put that in the wrong place. I was about to say that. I forgot my equal sign. You know better than me, so you do better than me. No, I'm human. I'm not a robot. That was a typo. All right, so we have 1 plus 0.06. Really? How do you know I'm not a robot?
We don't know for sure. Miss, we didn't take a test.
All right, so there's a couple ways. There's a couple ways to solve this. Way number 1 is algebraically and then using a calculator. Way number 2 is all calculator. So I'm going to model both. Way number 1 is that in the calculator, I would just evaluate and then divide. Does that make sense? Evaluate this and then divide it on both sides. Yes? Because that would get my P by itself. Agreed? So we're going to do that first. So if we did this part, evaluate it, and we're going to divide it on both sides, and we get the value of our P. So I come over here, and I'm going to plug in parentheses 1 plus 0.0625 divided by 2, close parentheses, shift 6, parentheses, 2 times 15. 2 times 15. So we end up with, this is 2.5172, right? So when I come back over here, we have 2.5172. That's what this equals. That's what we're dividing both sides by. So this will be canceled out, and P would equal whatever that is. So P equals, so I'm going to go back to my calculator, and I'm going to type in 5,000 divided by 2.5172, and we get that it's equal to about, that was our original. Does that make sense? 1,1986, and how much change? 33 cents. Okay. Exactly. Thank you for acknowledging that. All right. Okay. So now that's algebraically. Okay. Now we're going to talk about solving it graphically. So solving it graphically means that since you have an equation with one side equals something and another side, you're going to put them both in. So I have y equals 5,000 because that's my left side of my equation, correct? And then we had y equals the right side of my equation. P is my unknown, so we're going to put it in as x because it's unknown. And we have 1 plus 0.0625 divided by 2. And I'm going to go ahead and just put it to the 30. Is that okay? Because 2 times 15 is 30. Okay? So once you create this, what you're doing is looking for the intersection of these two. I'm clearly going to have to zoom out a whole lot. And I zoom out, and what does it tell me? Does it tell me the same thing? Yep. Do we still get 1986 and 33 cents? Yes. Okay. So do we see the algebraic versus the graphic? Doable? All right. Awesome. All right. Now, what if the value is decreasing? Well, if the value is decreasing, the only thing that changes is instead of you 1 plus r over n, it becomes 1 minus r over n. That's all you're doing. Got it? So when it's decreasing, our plus becomes a minus. Everything else is staying the same. Okay? Make sense? All right. So I would like for y'all to use that. Knowing that, you're going to do the last example. Okay? So go. All right, my friends. How did we do? How do we feel? Why didn't you finish? Okay, did you at least get it written down? All right. So it says the value of the new car is $12,500. So that's it is our P, 12,500. Our P, right? It's 20%. So our R and our per year, which is our N, and then 3 years, which is our T. Okay. So we're looking for A of 3, which equals 12,500 times 1. Because it's decreasing, what changes here? Minus. And it becomes 0.2 over 1. I'm just writing it so we can all see it, right? To the 3. Yes? Makes sense? So once you plug all of that in, what did you guys get is the car's value?
6,400.
6,400. So after 3 years, the car, what, did anyone open the door? Oh, would be 6,400. All right. How do we feel about compound interest? Okay, so you have your compound interest assignment. You go to settings. So now it becomes what?
Tomorrow.
Homework. I don't see you tomorrow.
Work for Monday.
You'll have time to peer check on Monday.